Hey guys, so today we're going to be defining polynomials, specifically section 3.1 in our workbooks, so let's get right into it. We're first going to look at the standard form of a polynomial expression. The standard form of a polynomial expression means that it is written with the terms in a descending order of the exponents. This makes it easy to view and simplifies the expression. So what is a polynomial? A polynomial is an expression that consists of variables and coefficients. Polynomials include operations of adding, minusing, and multiplying. So the equation below is just an example of a polynomial. This is what we're going to be going off of today. So in a polynomial, there are certain things such as powers, exponents, and coefficients. So powers of the variables must be a positive whole number or a zero. Exponents has to be a whole number, and coefficients also have to be real numbers. So when we look at this polynomial, we can see that it is a polynomial because each of the exponents are whole numbers and all of the coefficients are real numbers, making it a polynomial. So these are two examples of non-polynomial expressions. The first one, the exponent is not a positive whole number, making it not a polynomial. And the second example, square root of -3 of x is not a real number. So again, this is not a polynomial. So now we're going to get into the different parts of a polynomial. So let's start with degree. The degree of a polynomial is the highest power of a variable in an equation. So in this equation, the degree is the 4 because it is the highest power. Now let's look at coefficients and the leading coefficient. So coefficients are the numbers in front of the variables in the expression. So the examples of coefficients would be the 5, the 4, the 3, and the 2 because they are all in front of the x. The leading coefficient is the coefficient with the highest power. So, since the highest power is the 4, the leading coefficient would be the 5. Okay, so now terms and constant terms. A term is a single expression a part of the polynomial. So, for example, 5x to the 4th would be a whole term. Constant term is when there is a term without a variable. So the 1 would be considered the constant term. So there are special terms for polynomials. Each of these special terms are identified by how much the degree is. So when used the word constant, the degree must be 0. When we're using the word linear, the degree must be 1. If it's quadratic, the degree must be 2. Cubic must be a degree of 3, quartic must be a degree of 4, and quintic must be a degree of 5. So the example on the right has a degree of 4, meaning that the special term would be quartic. So let's have a look at polynomials on graphs. So the first one with the red writing, this polynomial function is considered a polynomial because it is one line. There's no breaks or corner. A non-polynomial function on a graph would have something such as a break or a corner. So let's look at the slopes of polynomials on graphs. So here we have 4 different examples of the slopes of polynomials on graphs. So we can see that each of them have positive and negatives where they start and end. This is just 4 good examples of knowing where your slope should end and begin, if it's positive and if it's negative. So now let's look at the end behavior of a polynomial. How do you find end behavior? So using the standard form of a polynomial, when it does not equal 0, the end behavior is determined by the leading term of that polynomial. So now let's use degree and leading coefficients of a polynomial to help graph it. So the first step is to find and look for the leading term. So the first term in the equation. The exponent, the n in green, will determine the shape of the function on a graph. The coefficient, the purple a to the n, will determine which direction the function is going towards. So these are some really important examples that you should remember when graphing a polynomial expression. For y equals ax to the n plus, if n is an even whole number and if a is more than 0, the graph will start up and also end up. That means that the starting point of the graph should be starting up and the ending point should also be starting up. This example on the left is just an example of what that should look like. For y equals ax to the n plus whatever, if n is an even whole number and if a is less than 0, the graph should start down and end down, meaning that the starting point and the ending point both should end down. Again, this is just an example of what that should look like. So here is 2 other examples. When n is odd, a whole number, and if a is more than 0, the graph starts down and ends up. This is just an example of what that should look like. If n is an odd whole number and if a is less than 0, the graph should start up and end down. So on the right, this is just an example of what that would look like. So remember, if the degree is odd, points on the graph will end in opposite directions. So an example would be the starting point would be positive and the ending point would be negative. If the degree is even, the points on the graph will end in the same direction. Example would be starting down and ending down. Now we've been able to cover how important the degree and leading coefficient can be in a polynomial. Let's talk about the constant value / term. The constant value / term is the y-intercept, where the points cross at the y-axis. So when we look at the image on the right, the constant term is 6, meaning that the polynomial on a graph will cross the y-axis at 6. So let's do an example. For this example, the question is, find the y-intercept of the polynomial function. The function is f of x equals -2 x plus 1 third. So the step 1 is to set your x's to 0. So we're going to set the x of f of x to 0 and the x in the bracket to 0. Step 2 is to add all of your numbers together. So what you do is first add the 0 and the 1. Then you would times 1 by 1 by 1, and then times that by -2. That gives you -2. but we still have a 0 with the f of x. So your y-intercept would be 0 and -2. That means when you graph this, the y-intercept would be -2. So your graph would cross the y-axis at -2. Now we can't forget about the zeros. Zeros are where the function crosses at the x-axis. They are known as the x values of the function on a graph. So remember, if f of x is the function and a is a real number, x equals a is the 0 of the function. X equals a is a root of the function. X equals a is the solution of the function. Bracket x minus a is the factor of a function. And bracket a and 0, a is the x-intercept of the graph. So let's do an example. The question is, find the real zeros of the polynomial function. So we are trying to find the x values. The function is f of x equals -3x4 plus 3x squared. The first step is to factor. So when we factor, we get f of x equals -3x squared bracket x squared minus 1. And if we bracket again, factor again, it would be f of x equals -3x bracket x minus 1, x plus 1. So -3x squared would equal to 0 if you divided by the -3 and square root. The x also equals to 1 and x also equals to -1. So your three zeros are 0, 1, and -1. So now we are able to find the zeros. Let's find the minimum and maximum intersections on the x-axis. So to find the minimum and maximum intersections, we want to use the degree, also known as n. So when n, also the degree, is an even number, it can intersect the x-axis 0 to n times. So say that the degree was 2, it could intersect the x-axis 0 to 2 times. When the n is an odd number, it can intersect the x-axis 1 to n times. So if the degree was 3, it can intersect the x-axis 1 to 3 times. So let's do some examples. The question is, what is the minimum and maximum number of intersections on the x-axis? So here we have to find the degree first. For this equation, the degree would be 5. Since the degree is an odd number, the minimum value would be 1, and the maximum value would be 5. Looking over at number B, y equals 3x6. 6 is the degree. 6 is also an even number. That means that the minimum value would be 0, and the maximum value would be 6. So let's look at some graphs. Now we're going to talk about turning points on a graph with a polynomial function. So to find the turning points of a polynomial function on a graph, we need to use the degree, also known as the n. So the polynomial has an n amount of times of turning points. It is the minimum degree is n plus 1. So when we look at the graph on the right side, it has 4 turning points where the graph turns in a different direction 4 times. So using n plus 1, we look at the photo on the bottom left. 4 plus 1 is 5. So the minimum degree is 5. Okay, let's talk about the last important thing of a polynomial, the multiplicity. A multiplicity of a 0 is the number of times the factor appears in the factored form of a polynomial. So, let's give an example so we can understand that a little bit better. So the question is, find the real zeros and multiplicities of the zeros of the polynomial function. So we need to remember that when it says real zeros, that means x values. So we have the polynomial function here. F of x is equal to x squared minus 4. Our first step is to factor. So we have f of x equals bracket x minus 2, bracket x plus 2. So when we bring those out of the brackets, we have x equals to 2 and x equals to negative 2. We have a multiplicity of one of each because there is no number on the right side of the bracket. If these brackets were both squared, the multiplicities would be 2 for both. When there is no number on a right side of a bracket, the exponent is a 1, making the multiplicities both 1s. Now we have learned all about polynomials, let's do a question from our workbook. The question is, determine end behavior of a polynomial function. The polynomial function is f of x equals 2x plus 3x squared. So the first step is to remember the standard form for a polynomial is y equals ax to the n plus whatever. So the first step is to put your equation into highest to lowest terms. So I had first moved the 3x squared to the front and the 2x to the right because it's easier for me to see what the degree is. Now we're going to look at the leading coefficient and the degree. So we can see that the leading coefficient is the 3. It is a more than 0 and the degree is 2. It is also an even whole number. By knowing that, we can see that the graph will start up and end up. Well, that's all that we have today. Thank you for watching. I hope that you understood.